In this video, we are going to talk about arithmetic, sequence, and series. Okay. So what is a sequence basically? Sequence basically is the collection of the objects, mathematical objects in particular. For example, the numbers like this 1, 2, and 3, right? It is a collection of objects. Now you will say the set is also a collection of objects, right? Yes, correct. The set is also a collection of objects. Then what is the difference between set and sequence? The sequence has a certain order, right? So I can write this 1, 2, 3, 4 like this, right? I cannot change the order. I cannot write the same thing as 2, 3, 1, and 4, and so on, right? This is not allowed. This is an entirely different sequence. But in the case of set, you are allowed to write it like this, maybe 3, 2, 1, and so on, all other elements as it is, right? So this is one difference between sequence and set. And in set, you cannot repeat a particular object twice, right? Or more than twice. Okay. In the sequence, the number can be repeated. You can have a sequence like this 1, 1, 2, 2, and 3, 3, right? But in the case of set, you have to write 1, 2, 3. Okay. You have to write it only once, right? This is the basic difference. Now, in this video we are going to talk about a sequence which is known as arithmetic sequence. So what is arithmetic sequence? I will write one sequence here 2, 4, 6, 8, 10, and so on. Now what you can observe from here, this is a sequence of even numbers, right? So now how will I relate the 4 with 2? If I add 2 to the 2, then it will become 4. If I add again 2 to the 4, it will become 6. If I add 2 to the 6, it will become 8. Now you can see the difference between the consecutive terms is going to be the 2, right? Between 8 and 6, it is 2. Between 6 and 4, it is 2. So the common difference, that is D over here, we will write it as a D, is going to be 2. This is called common difference because between consecutive terms, this is going to be the difference, right? Okay. And this is written as A0, the starting term. We'll call this as a starting term, A0. It can be anything. In this case, it is 2. Now, in general, I can write this as A0 if I don't know the first term. And the common difference is D. That means it is going to be A0 plus D. Now again you have to add D into this and it will become A0 plus 2D. Again I add D to this, it will become A0 plus 3D and so on. It will continue, right? Till the nth term. Now the question is how you will write the nth term, right? So look here, this is the second term, right? This is the third term. This is the fourth term, right? So nth term will be written as A0 plus, see for the second term it is D, for the third term it is 2D, for the fourth term it is 3D, for the fifth term it is 4D. So for the nth term it should be n minus 1 into D. So this is going to be the n term. So I will write an as A0 plus n minus 1 into D. This is the n term of the arithmetic sequence, right? So given any A0 and B, you can find what is going to be the nth term. So for example, a quick question I can ask you, if A0 is 3 and the common difference is 2, then tell me what is the 10th term of this series. Now just you put an value to be the 10, then you will get A0 is 3 plus 10 minus 1 into the difference is 2. So this is going to be 3 plus 9 into 2. It is going to be 3 plus 18. That is going to be 21, right? So this is going to be the 21, right? So this is easy. Now, this is what a sequence is about. Now, there is one more thing that we are going to study that is called a series. What is a series basically? In sequence, you can observe the two numbers are separated by a comma right here. Now, in the series, they will not be separated by a comma. They will be separated by a addition symbol. That means series is nothing but the addition of all these terms, right? So the series is about addition of the terms. So series will be A0 plus A0 plus D plus A0 plus 2D and so on, right? So the addition of the terms of the sequence is nothing but the series. right? Now, I will take you back in time very long ago. There was a class which was very noisy. The teacher wanted them to shut their mouths, right? So as a result, he gave him the work. He gave all of them the work to add the numbers from 1 to 100. So you have to add 1 plus 2 plus 3 up to 100. So all of them started adding these numbers, right? And all the class went quiet. There was one person who did within seconds. Okay. What this person did, what he did was he wrote all these numbers 1 plus 2 plus 3 up to 100. And after that, he wrote again the same series but in opposite way. So this is 100, this is going to be 99, this is 98, and so on up to 1. Okay, again he wrote the same series but in the reverse direction. And then what he did, he added this series term wise. So this 100 plus 1 is going to be 101, 99 plus 2 is 101, 98 plus 3 is 101 again, and if you keep on adding it, it will be 101. So all the terms are identical of this series, right? And these are going to be the 100 terms. So that means the addition of these is nothing but 101 into 100, right? This is the addition of this. But now he wants the summation of these 1 to 100 terms, and he added this thing twice. So he have to divide it by 2 to get the answer. So to get the answer, what he gave is 50 into 101. That is going to be 5050. So this is the answer he got within the seconds. And the name of the person was called Frederick Gauss. Okay, or you can say Gauss. So he was a great mathematician, right? So this is how he did it. So the similar way we are going to find out the sum of the series of n terms. Okay, so arithmetic series over here. So what is the sum of n terms? What we will do here, I will write in the similar way the terms of the series a0 plus a0 plus d plus a0 plus 2d up to a0 plus n minus 1t. As I told you, it is the n term is going to be n minus 1 into d, right? Now again, write the same series in the opposite way, that is the reverse way. So it is a0 plus n minus 1t up to here you will get a0. Now add these terms, okay, add these terms here. So what it will give you, right? So this will add up to 2a0 because a0 plus a0 is 2a0 plus n minus 1 into d. And all these terms, see the last term over here is 2a0 plus n minus 1 into d, right? Now all these terms are going to be the identical terms, and there are n terms like this, right? This is the first term, this is second, this is third, this is nth term. So now if I add it, okay, so each term I am adding n times, that is, it means I'm multiplying this each term by n. But now I have added them 2 times, so I have to divide by 2, right? So this is going to be the sum of the arithmetic series. Okay, so this is going to be n by 2 into 2a0 plus n minus 1 into d. This is going to be the sum of the first n terms of a arithmetic series. Arithmetic series. Some people also call this as arithmetic progression. Arithmetic progression. Some people also call this as arithmetic progression. Okay, now let's do a question. Okay, let's see if our formula is correct or not. So let's say a series which is 2, 4, 6, and 8 up to these numbers. Okay, so we know the summation of this. This is going to be 10 plus 2, 12, 20. Let's say it is going to be 20 or not. So what you do, sum of these first four terms is going to be, these are the four terms here. So this is 4 by 2 times 2 times a0. A0 is 2 in this case. 2 plus n minus 1, that is 3, into the common difference is 2. This is going to be 2 times 4 plus 6. This is going to be 20. Yes, in fact, this formula is correct. Okay, so that is good. Now, the thing that I will do here is highlight the importance of the common difference. See, the common difference does not have to be positive as always, right? It can be negative as well. D can be less than 0 as well. Okay, there is no such a thing that common difference has to be plus 1. I can have a series like this minus 1. Okay, the common difference is minus 1, then it will become minus 2, then it will become minus 3, then it will become minus 4, then it will become minus 5. All the things will be same. The common difference is going to be minus 1, minus 1, minus 1. So D is going to be minus 1. Okay, and A0 is equal to minus 1 also, can be also minus 5. Okay, so it doesn't have to be always a positive number, it can be negative number as well. So this is all about arithmetic series. Thanks for watching the video.